day and a half so far, and sort of brimming with ideas and thoughts. And before I start my talk, the first thing I really want to do is acknowledge my partners in crime, Leon and Ron and Mike and Rafi and Lucia, who together with me have been part of this working group for the past several months on deconstructing and reconstructing consciousness, of course, and this is sort of the culmination is this meeting. And it's been really great fun and an incredible learning experience for me. I feel a little bit guilty, though. I feel like a sort of, imposter syndrome to the extreme in some sense, partly because maybe now's a good time to share a deep, dark secret, which is I really don't study consciousness. In fact, yes, so I'll get there. In fact, my work is really focused on a very, very different, at face value at least, question, which is really trying to understand how memory, learning, past experiences shape the decisions we make. But in some sense, it's really actually worse than not studying consciousness. It's that for many years, I've had a very strong, almost suppression or resistance, negative criticism of the idea that consciousness is a useful way to be thinking about questions about memory and decision making. And so I think for many years I really felt that consciousness does not help us understand memory and how it guides behavior, and in fact that the notion of consciousness has historically in the field really interfered with our ability to understand how memory works and what it does for us. And I think I've come around over the past several months to really thinking differently about this, which is the idea that actually understanding memory as memory and its basic mechanisms, and relative to other cognitive functions, I'd argue we understand quite a bit about how memory works, how we use it, and what its neural mechanisms are. And that this understanding may actually surprisingly, to me, help us understand consciousness. And I think that's really something that I felt I learned through interactions with my colleagues. And so what I want to do today is really sort of describe for you, I guess this goes back to the talk we just heard from Roy, my own self, my personal experience of sort of the passage from this before and after, of how my perspective has shifted, where it came from originally and where it stands now, and where I think it might be useful to think about what we know about memory to understand processes of consciousness, conscious awareness. So I'm going to start with sort of just a brief, very, very brief summary to get us all on the same page, because we haven't really talked about memory in this room since yesterday, about why we would even think or how we would traditionally think about the relationship between memory and consciousness. And then I'm going to give you one example of why I think thinking of memory as a source for decision making changes the way we think about memory and should therefore challenge the way we think about consciousness in memory. I'm going to give you one study as an empirical sort of example of how we're thinking about that. And then I'm going to turn to another study, time permitting, that will talk a little bit about how a study of memory might shed light on basic questions about the gap between our subjective experience in the moment and the way we consciously report that experience, which I think is not really a question that was formulated to ask questions about consciousness, but it seems to me to inform such theories. So just, sure everyone in this room or on YouTube knows this, but here's patient HM, just as a reminder that patient HM really transformed the field of memory, and he suffered from intractable epilepsy, underwent neurosurgery that removed his hippocampus and surrounding medial temporal lobe tissue, and then presented with a very, very, very severe and highly selective memory deficit, where he was unable to create new memories of people, places, and moments in time. And one of the most striking features, of course, of HM's deficits, and this has been replicated with many patients moving forward, was its selectivity. So despite this inability to create new memories of moments in time and report who the doctors were, what happened yesterday morning, other forms of learning remained intact. And this observation, this pattern, was revealed really by very, very careful neuropsychological studies done by Brenda Milner and Sue Corkin on the deficits, and led to this very, very striking view of what the hippocampus is important for and of how memory is organized in the brain. Right, so the conclusion from these studies and subsequent studies was that the hippocampus is necessary for declarative memory, that the hippocampus is necessary for memories which we can verbally report. Okay? And the subsequent or related conclusion was really that conscious awareness, in this sense, as a theoretical conclusion, was really sort of put forth as the critical distinction between memory systems in the mind and brain, sort of fundamental to the Larry Squire view of the world, that we have at base, all forms of memory should be distinguished as either declarative, therefore consciously aware in their nature, verbalizable, reportable, or not. So explicit, implicit, declarative, non-declarative. This is what most of us still have in our textbooks and teach our students. And so it's really been a fundamental turning point in the study of memory. It was been a very fruitful framework in many, many ways. And you know, when someone says that a framework was fruitful, you know what's coming next. Right, so there are three main problems with this conclusion. The first, I think, which sort of really struck me this year looking back, is that basically what happened at that moment in time, was this idea that we can explain one unknown, like the organization of memory, with another unknown, conscious awareness of those memories. So that's problematic, and I really think it's that issue that led to subsequent kind of reverse inference or circular logic, where for many, many years, anything that a patient like HM, or with a similar form of anterograde amnesia, anything they couldn't do, it was inferred often by the researchers, by us as a field, that that process must involve conscious awareness or consciously accessible memories. And so it led to this, I think, somewhat absurd situation of thinking about how to classify tasks in terms of cognitive function based on whether or not they survived after hippocampal damage. So the sort of the circular logic between the anatomy and the cognitive function. The third problem is that it actually turns out that it just doesn't hold up with data. And I think this has really been, at first, off-putting to many of us as students in the field, but then really kind of striking. And I think that's where we are now. So here's a list of just some things that we would a priori, from first principles, think of as non-declarative, not involving conscious awareness, but that are impaired in patients with hippocampal damage and that have shown with functional imaging to be associated with bold activity in the hippocampus. Priming is a great example. It shouldn't, from a textbook point of view, involve hippocampal function, but it does. Nick Turk-Brown has done an incredibly systematic series of studies demonstrating a role for the hippocampus in statistical learning. We've and others have done some studies on sort of automatic inferences and decision-making. Even spatial navigation, which we assume must involve conscious awareness because it depends on the hippocampus, but I think there's some sort of fallacy in that thinking as well, prospection and other kinds of functions. And so I think where this leaves us is sort of with being forced to rethink both what the hippocampus does, but also really how we want to, from a theoretical point of view, organize our understanding of how memory works and how it's organized into different parts of the brain. So the idea is not that consciousness isn't relevant to memory, nor that all parts of the brain are doing the same thing, but I think it really left open some fundamental questions about what the hippocampus does. So one conclusion then is consciousness in of itself does not really explain memory and its organization in the brain. But I think, and this really goes back also to Lucia's talk yesterday, that maybe considering the role of memory in guiding decisions, whether consciously or unconsciously, can offer some insights into how we should be deconstructing and reconstructing consciousness in general. Okay, so what I want to show you next are sort of some data that bear on this. I want to show you sort of one example, which to me is kind of one of the most extreme examples of where we find a kind of critical role for the hippocampus in guiding decisions. I'm not going to come down strongly on whether this process itself is consciously aware or not, but I want to provide as an example of something that sort of doesn't fit with our conventional way of thinking about things. And it has to do with a very seemingly simple decision. In this case, the decision, you should all kind of engage in this. If you were offered a Kit Kat and M&Ms, which one would you choose? M&M. So that was a pretty fast reaction time. So my daughter one Halloween was facing this decision because we only let her have one snack, and she just couldn't decide. She really, really, really was tormented, and it was, her sister had finished her chocolate minutes ago, and she still couldn't decide which one she wanted. So some decisions are very difficult for some people, and for my daughter, this was a very difficult decision because, I said, why is this so difficult? She said, because they're both my favorite chocolates. Right? And so this is a phenomenon I can tell you I'm well aware of and have experienced myself, but most of us are, that if we're trying to choose between two things that we like equally, that's a difficult decision. It slows us down, and we know from a lot of empirical work that these decisions, in fact, come with much longer reaction times when people are deliberating. And this is a really puzzling phenomenon, partly because, as in my daughter's case, she's really sort of putting off, delaying the reward. And we know that we like rewards as soon as possible, generally speaking. So in some ways, it's sort of a counterintuitive phenomenon, especially in the positive domain. The other reason it's interesting is because if you actually do this experimentally, I'll show you data in a moment, what you find is this, as I mentioned, this sort of classic finding that people take longer. And that profile of taking more time to make a decision between things that are similar is exactly what Mike Shadlin described yesterday when we were making perceptual decisions, right? If you have to decide whether dots are moving left or right, it takes you longer if it's the difference between the leftward motion and the rightward motion is smaller. And so at first glance, it just seems like we can take this idea of evidence accumulation and apply it equally to decisions about dots and decisions about foods or other things that involve preferences and choices. But if you think about it a moment later, when you're looking at the dots, you are actually getting more evidence with more time. You're getting more evidence about the motion. And I think this really raises a fundamental question that we became very interested in, which is, what are you doing with the extra time when you're trying to decide between a Kit Kat and M&Ms? Looking at it longer isn't really helping you. And we thought, actually, this might be exactly the sort of case where memory is exactly what you need, because you need to be probing some kind of richer model representation that will help you probe the past, think about the future, and that is the evidence, that the evidence is internal. So that's the intuition. The fundamental question we were asking here is, why do these difficult decisions take more time? And we hypothesized that memory mechanisms are involved in considering the options and generating samples of evidence. And this is work done together in collaboration with Mike Shadlin, joint postdoc Akram Bakour, and Ariel Zilberberg. Okay, so the idea, just to be super explicit then, is that for decisions based on internal evidence, the hippocampus may supply that evidence. And because more difficult decisions require more evidence, that is why they require more time. And so the prediction or the question empirically then is, do longer decisions actually engage the hippocampus more? And then the sort of correlated or corollary question here is, do people with hippocampal damage actually have differences in how long it takes them to do these sorts of deliberations? The short answer is yes to both, but let me show you how we did that. So in this study, we had people engage in a series of these sort of value-based tasks about these snacks, which the undergraduates really like. And then to kind of control for things related to reaction time and choice and all the visual processing and so forth, we had the same participants also do a very simple perceptual task. In this case, they have to determine whether there's more blue or yellow dots on the screen. So in one case, the evidence is internal. In one case, the evidence is external. So we can compare reaction time for food choices, controlling for reaction time, and decisions in general. So let me show you the data first in terms of behavior. Here's what people do. So on the x-axis, I can use this. Can you see that? Yeah, they're on the x-axis here is value difference. So here's the 0 point, the point of indifference in value. We collect subjective value from all the participants for each of the snacks, so we know how much they like them. And what I'm plotting on top is the probability of choosing one of the items. So this is, in a sense, accuracy. How consistent are they with their own preferences? And on the bottom is reaction time. And what we see is exactly what's been shown before, both for perceptual decisions and value-based decisions, which is that people are pretty consistent, and the reaction time is longer as people slow down at that point of indifference, and you see the sort of characteristic curve. Those are the drift diffusion model fits. For perceptual decisions, we see, again, what people have shown before, basically the same thing. Accuracy as a function of the difference in color coherence. Here, again, point of indifference is a 0, and here's the reaction time curve showing the same thing. So it does take more time to decide between options that are closer in value or closer in color coherence, and really the question here is why. So I want to give you sort of, without going into too much detail, kind of an intuition and the flavor of how we're asking the question of why first in the fMRI analyses. So these are healthy young participants who are undergoing brain scanning while they're doing this experiment. And we really wanted to kind of probe two separate functions. One has to do with time, because that was our central hypothesis. So we want to ask, are there any differences? We can compare the reaction time regressors between the tasks. We have for each participant, for each trial, the reaction time. And we can include that reaction time for each participant, for each trial across both of the tasks, and ask in general, when we compare value-based decisions and perceptual decisions, do we see differences in the parts of the brain where bold activity correlates with the reaction time? So that gets at the question of time. But we really had an important question here. So this is just a schematic showing you that. But an important question here about memory. And here we were a little bit stuck, partly because it was very important for us that we ask people to do a task that is in many ways has ecological validity, and that we're not requiring people to report their memory. We wanted to see, does memory sort of spontaneously contribute to these kinds of decisions? And yet we wanted to understand how much this is related to memory function specifically. So what we did is we had a separate kind of localizer for memory retrieval. The same participants that did the value-based task and the perceptual task also did a simple memory retrieval task for objects. And so we can now ask for each participant in their own brain which parts of the brain are showing activity related to memory retrieval. And then we can do, is sort of a classic fMRI kind of approach, we can do a conjunction analysis. We can ask, where are areas that care about time for value more than perception, and areas that also care about memory. And the result is that we find significant activity related to both time and memory for value-based decisions more than perceptual decisions in the hippocampus. So memory-related regions identified subject by subject are showing more bold activity correlating with longer reaction times, especially for value-based decisions. The really important question here for us had to do with necessity. I feel like there's a whole long story one could go into about many, many findings related to hippocampal responses in various tasks that appear to be at least not typical declarative memory tasks. And I myself and many others have said for years, yes, but show us the lesion data, right? Show us that hippocampal damage affects these particular processes, and that it's not some spurious correlated activity that we sort of might be getting with fMRI, which is not in a good position to test causality of particular region for a particular task. So I'm going to show you now data from a study we did that paralleled this fMRI study, but with patients with hippocampal damage. So these patients, this is in collaboration with Mika Verfay and Daniela Palambo. And I'm going to show you data from 6 amnesic patients. These patients are very much like HM. They present with this anterograde amnesia. They're characterized and defined as patients who show intact cognitive function on every measure except long-term memory. So in that sense, just like HM, I was going to say they're better than HM. What I mean by that is, as opposed to HM, who had hippocampal damage and damage outside of the hippocampus in an individual subject, is these patients have all been well characterized as having damage that at least can only be detected in the hippocampus and not outside the hippocampus. And so now I'm going to show you behavioral data from these patients and matched controls on these two tasks. First, let me show you the control data that look just like you'd expect here for the value-based decisions, perceptual decisions, accuracy again on top, and reaction time on the bottom. Now for the amnesics, you might expect all kinds of different, you make all kinds of different predictions. The first thing we wanted to test is, can the amnesics perform this perceptual task as we'd expect them to? So I'm going to show you the amnesics here in red. And here on the perceptual test, you can see that they're just as accurate. They are numerically a little bit faster, actually, on these perceptual color coherence decisions, but that's not a significant difference. So our conclusion here is really that at least when you look at this sort of task, this is, this allows us to keep our textbooks intact. Yes, patients with hippocampal damage show perfectly fine, perfectly normal on perceptual decisions. When we look at the value-based decisions, what we see, however, is somewhat more stochastic, more noisy decisions in terms of accuracy. And actually, it's remarkably to us, despite sort of similar expectations, but I think the extent of this effect was surprising, they're much slower and they're significantly flatter in their reaction time delta value curves, right? So again, 0 is the indifference point. And here in red are the amnesics, and in blue are the controls. And this is a really, I think, to us, surprising fact, and we can get into it more in the Q&A. And I think what's especially remarkable is it really shows that the difference in reaction time is not explained by differences in accuracy. So there's really something about the deliberation time that's different in the decision-making of patients with memory damage. So hippocampal damage selectively impairs value-based decisions and not perceptual decisions, and specifically the timing. Here are the individual data. I just showed you before an average of the 6 participants. I think it's crucial, especially with these sample sizes. So these are all this is sort of individual data for the amnesics, and you can see that really they all show this sort of slower, flatter curve to different degrees, and similar for accuracy. And here's the perceptual data. Okay, so far, showed you that the hippocampus contributes critically, in the sense that it's necessary, to the timing of deliberation about value. And again, that this is even for choices that don't at face value demand the use of memory. So I should say that the items we used for the snack value-based task, we made sure they all could recognize the items. We used somewhat simpler items like apples as opposed to things with a lot of writing on them. So it was not a memory recognition effect. They could recognize the items. They were in fact consistent with their own preferences, and yet they show this effect. And so I think this is important, and because it really gets to the idea. It's not because we're asking them to memorize anything at all. We're not asking them to use memory. We're sort of trying to just capture it, do they? And I think this, to us really sort of speaks to this question of what is memory for? And is that a useful question to ask when one wants to understand how memory works? And I want to here sort of, come back to Liad's comments from yesterday. Liad made a really strong case and a compelling case for why, if we want to study consciousness, we should put it in an ecologically relevant environment. But she was perfectly willing to let those of us who study memory if you want to study memory, you just study lists of words. But I'd say no, I think that's a big mistake, that really we're missing the point in very much the same way you were describing for consciousness, that if we don't ask how people are using memory to guide behavior, then we're not really understanding how memory works and what it's for. And that instead of being there so that we could remember lists of words, that the point of memory is really to guide behavior and to guide our decisions and actions on a kind of, I'd say, really continuous basis. Okay. So in the last part, I want to turn to show you a somewhat unrelated study, related from our point of view, somewhat, I think, dovetails with separate issues in studies of consciousness, which have to do with something we talked a lot, and I learned a lot about in this working group, about this idea that how do we measure conscious awareness? If we're interested in the subjective experience, then we have to ask people, one way or another, to report their subjective experience, right? And for me, as somebody who studies memory, the idea that what people say about their subjective experience actually reflects their subjective experience in a faithful way is difficult, because our memories are so biased in all kinds of ways that is really sort of got interested in this idea of the kind of experience memory gap, and to what extent are people accurately reflecting, reporting on an accurate experience when we're asking them to report from memory. So this raises really a question about sort of the subjective experience versus the reports from memory of one's experience, and kind of from within the lab, our perspective on this question really would be to ask questions about can or how does value modulate our memory for events, and can we have value modulation of our memory even when we don't have value modulation of our experience. And I think that really gets to the heart of this kind of paradox in thinking about memory as being adaptive at all, which is that so often in our experiences, we don't know that something will turn out to be relevant, right? We sort of have to have this, talk about, sort of fairy dust, like how do our memory systems deal with the fact that something really important might happen in 5 minutes. It could have been predicted by what's happening now, but there's no hint of that happening now. And this, I think, really happens all the time. One other way of thinking about that is how our memory is prioritized by reward that it comes after the experience itself. So I want to share with you just briefly an experiment we did to get at this. And what we did is we had people come to the lab and play this game where they were looking at, they were navigating a maze and they're looking for reward. And if they get the reward in the maze, they actually get a reward in real life. And they're doing a series of mazes like this. So they control, and so I'm going to show you a demo. Let's say you're navigating this maze. We start you off here, and you're looking for the reward. So you're looking for a gold coin. And there it is. Okay, so if you found a gold coin, you basically get $1 in the task. And so what we did here is we had people navigate a series of mazes. In the data I'm going to show you, they navigated 11 mazes that ended with reward and 11 mazes that ended without a reward, and those are kind of randomly counterbalanced. And the mazes had between 3 and 15 objects per maze, so you don't know when the reward is likely to occur. You're really just exploring for reward. And after they explored one maze, they had a short rest, and then they explored another maze. And then afterwards, we asked them to report their declarative recognition memory for objects they encountered along the way to reward. So these objects were not the reward. They really had no predictive value. In fact, each of the objects in this entire experiment, they only ever saw once. So there's no pattern here. There's no real statistical learning. And the question was, is there any difference between memory for the objects that preceded a reward outcome in the maze versus objects that were preceded by that were followed by no reward? And we did this memory test under two different conditions, either after 15 minutes of the exploration task or after 24 hours. I'm going to not share with you yet the rationale for this question. Perfect. For why we looked at these two different time points. What I do want to share with you is the data. So what I'm going to show you here, on the x-axis is what we're calling sequential proximity. So here's the end of the maze. Okay, and this is basically distance from the maze. And we're going to look at memory for each of the objects as a function of how far they are from the end of the maze, that end of the maze either being a no reward or reward. And this is the likelihood of memory, sort of model estimate. So I'm going to show you that for the test after 15 minutes and after 24 hours, the same measurement. What we find after 15 minutes is essentially, in most cases we've done this now, I think there's 6 experiments in this paper. We've now done about twice as many in the lab. In some cases we find, in the one I'm showing you here, a difference between reward and no reward, but really no effect no significant effect of distance from end of maze. But what we find across all experiments we've done is this, I think, really interesting interaction between reward and no reward and distance from the end of the maze, showing that basically what reward does is sort of changes the trajectory of one's memory as a function of distance in space and in time from the end of the maze. So this basically shows that reward retroactively enhances memory for those sequences of events, but only after consolidation, those that end in reward. So the idea being that even though it's a one-shot deal, the events that are most predictive in space and time of a rewarding outcome are the ones that are remembered better ultimately, but that it takes time for that effect to emerge. And this, I think, really raises interesting questions about when these memories get tagged for consolidation or for this enhancement, because as I told you, when you're experiencing them, they're all neutral images that are not what you're looking for. So it can't be when you're seeing them. It can't be your subjective experience of the butterfly or the mug or the flamingo. It has to happen later, but it has to happen as a function of the reward. So it is clearly a response to the reward itself. It has to be happening then. And yet it emerges in terms of the consequences for memory really only after 24 hours. So the findings suggest there's a graded effect of value on memory for sequences of events that preceded it, that were neutral when you experienced them. And I think this is one of many examples that really show that what we remember is different from what we experience. And I think that has implications for people in this room. And just to really be explicit about this, there's two relevant time points after an experience that are important. One is seconds after the reward, and I didn't show you the data that support that, but please feel free to ask me. And the second is hours after reward, and this raises all kinds of questions about sleep, which I think Katerina will be speaking about after me. And again, I think this raises questions about what is memory for, and what do we gain by looking at memory in the context of sort of adaptive behavior. And again, that it's not there for accurate records of experiences, but what we have memory for and what we have a hippocampus for is really to adaptively bias the records of experience. Many of us would call this sort of a biased construction or a shaped construction of a world model that's there for future behavior, for guiding decisions and actions. So to conclude, I'm sort of slightly copied this format of thinking about the questions from Lucia's talk yesterday. So can we use hippocampal memory as a marker of conscious processing? I'd say definitely not. And actually this might be a good opportunity to to share. So Nick and I once organized a special issue and wrote specifically about this issue, but of sort of these non-declarative functions of hippocampal processing. And really the only reason, one of the reasons we did it, was that Ron asked us to. So I think it's the first time the three of us have been in the same room. It was several years back. But can we leverage memory to gain insight to subjective conscious experience? I'd like to think the answer is yes. So I've begun to come around to the idea that the answer may be yes. And so I think the hippocampus and memory are relevant to understanding consciousness, but not for the reasons we thought to begin with. And I just want to end with one anecdote. Some of you may have heard me refer to this before, but I think it really captures in a literary way an essential piece of this. So this is a book, The Giver. Has anyone here read it? A few people, great. It's a great book. I highly recommend it. It describes a dystopian society in which basically everything's there's no choice, there's no agency, there's no uncertainty. People are assigned jobs, people are assigned families, there's no weather, everything's completely predictable. One person in the society has the job of maintaining in his mind all the memories of the society before it became this dystopian society. So memories of snow and war and love. And the story tells how the person who has the job of keeping those memories is about to retire and has to give these memories to a young guy who will then be the holder of the memories. And there's a moment in the book where the boy asks, so the giver is giving the memories, the boy asks this person who's been holding the memories, why do we bother to keep these memories at all? And the older man says, well, we keep these memories because every once in a while the elders of our society ask me to advise them using these memories of the past. And the boy then asks him, do you advise them often? And he answers, rarely, only when they are faced with something that they have not experienced before. And I think this speaks to a wonderful intuition that what we have memory for is not so that we have kind of a record of something that happened 3 days ago because we don't know if we're ever going to use it. And it's not when that thing repeats that we really need memory. That really what we need memory for is for guiding us under situations of uncertainty rather than situations of certainty. And I think, again, that really speaks to the sort of ideas of when in a fluctuating environment, when we're sort of constructing our conscious experience, memory may be useful when things are maximally or more uncertain than certain. So with that, let me end with thanking the folks who actually did the work, especially Akram and Kendall. Thank you for your time.
Beautiful talk, Daphna. I had a question about the value-based decision-making study. So, you know, they come into it with preferences. Even the amnesics have preferences, and the amnesics are able to make the decisions, albeit slower and noisier. So I'm trying to think about what work the hippocampus is doing, exactly. And there's different ways of thinking about it. One could be that it's important for retrieving the value of objects, right? Some sort of value representation. An alternative is that it's retrieving past episodes or past choices that are not necessarily value representations but are more episodic. And so the more general form of this question is, are you thinking about it as sort of a declarative light thing where the function of the hippocampus is something like declarative memory, but that can inform decision making? Or do you think the actual value computations, updating, retrieval are driven by the hippocampus?
Yeah, great question. There's a lot to say about that. Very briefly, so in the experimental design, of course, this is kind of first study of what I hope will be a kind of long program. We don't know, right? So strictly speaking, we don't know exactly what it's doing. There is this really important hint, it's either a paradox or a hint or both, right? That, as you say, they're consistent with their preferences and they have no trouble telling us their preferences, nor do they need memory to know what that preference is, and yet they're taking longer. And the way we're really thinking about this is that it's a constructive process of deliberation that with an intact hippocampus is getting input from the hippocampus, probably mostly for kind of simulating and prospecting based on past experience into the future, and that it's this kind of rich envisioning or simulating or just selecting dimensions and reasoning through that is accounting for the differences in time. And that basically what's happening, and this is, I think, the paradoxical, kind of really interesting point, is that everyone's trying to do that, and the healthy people are succeeding. What's interesting is that the patients are trying to do that. I think they're trying hard, and that's part of what's happening with a longer reaction time. But even without doing that, they're falling back on a reasonable enough representation of their preferences to be consistent with their choices. So it suggests that, for the most part, we might not need to do that, but we're likely to do it all the time anyway, basically. I think that's our current thinking, so hopefully that addresses it. Yeah.
So I wonder regarding these amnesic patients, whether the deficit they have in decision making is a subtle one or a serious one, because what we know from patient data is that, like Damasio, the typical subjects that are thought to have problems of decision making are ventromedial frontal cortex, and HM was not probably characterized as having such problems.
Yeah.
So one more short question regarding the gradients you showed with this task. I mean, so it is true that there is an improvement for the last, but then there is a decrease for the, so they are equally predictive. So
Right. So two things. So first question first. I think that's exactly right, and I think that's a really important thing to emphasize, which is that, and that's why I think these sorts of results are really not at all what we read in the literature, right? What we read about is that patients with hippocampal damage have memory problems and not decision-making deficits, and the people with ventromedial prefrontal cortex have the reverse. And I think that's really, those are the kind of patterns that have led to these very separate chapters in our textbooks, and this idea of sort of, I'd say almost like cartoonish modularity of function, where we think that decision-making depends on one part of the brain and memory depends on another. And I think more and more results of this sort are starting to come out, and they're really helping us refine our understanding of where those boundary conditions are. And let me just add to that. So you asked, are there decision-making deficits subtle? I think they're very subtle, and I think that's why it's so important. And that's why I think this will end up being so useful, because I think it's these subtle deficits that will help us see very clearly where you do or don't need a hippocampus for deliberation, right? In the sense that you actually don't need a hippocampus to be consistent with your choices so much, right? That's something else that's going on. There's another example, work by our collaborator, Daniela Palombo, that shows, there's imaging work showing if you do a classic temporal discounting task, do you want $2 now or $5 next month, right? So people discount. They often go for lesser money sooner, okay? If you ask healthy people to make those decisions, but you emphasize an event in the future, so instead of $2 now, $5 next month, you say $5 next month when you're finished, taking your intro to psych class and you're at the shopping mall. That people discount less if you put it in a rich simulated future, and that change in discounting has been shown to be associated with bold activity in the hippocampus. And now if you take patients with hippocampal damage and you just do a straight temporal discounting task, a classic kind of value-based decision task, they discount at the same rates as controls. But if you do this manipulation on them where you ask them to think about in the future, they don't show the attenuation with simulating about the future. So I think I think there's a sort of new studies that are starting to look at cognitive function, especially in patients, not as decision-making or memory, but really is how do we use one to inform the other to try to find out where the boundary conditions are.
Oh, thank you for your presentation. And I remember that you say about the difference in reaction time of amnesiac people and healthy people in the perceptual task was not significant. But I'm thinking about, for example, to blind people that with lacking of vision, they're starting to rely more on the auditory or tactile system, and their brain modified accordingly. So it's not the same, for example, for amnesic people which lack in this memory retrieval. So they're starting to rely more in a perceptive way to act. So accordingly, they act more faster in a perceptual way respect to healthy human being?
That's interesting. So if I understand correctly, what you're asking is, setting statistical significance aside, is there some compensatory
They compensate
trade-off
because
here?
they not rely anymore on the memory, and
Yep.
so in some parts they start to act more faster.
I mean, I think we can, I don't know, I think we can, in our own data, small sample and all, address that by just looking, which we haven't, on an individual level, sort of how these two things move together. I don't know of anything of that sort that's been reported. I was actually just having a conversation related to that with colleague Scott Small at Columbia, who's a neurologist, and he shared that a patient with early Alzheimer's shared with him that she always felt her memory was bad, so she never relied on her memory, so she thinks she's going to be much better off dealing with Alzheimer's because she's used to functioning without a memory. She has all these sort of strategies she's developed. So just, kind of as an anecdote that relates to that. But I mean, I think really if you sort of look at the literature on amnesics, and we didn't intend to necessarily run these tests, we wanted to sort of comb through the literature and find data. I think the idea that all that is impaired in these patients and that all the hippocampus necessary for his declarative memory has been so dominant that there's just been very, very little data on other tasks with these sorts of patients. They're also hard to find and hard to characterize. So I think there are many, many questions really ripe to be asked of these patients. And I think if anything, I think it's striking. I thought this was what Nick was going to ask, because I think you asked me this about some other data like 10 years ago, which is, why don't they learn to not take longer? Like that, it's just, if they don't have it there, why do we, and we've seen that in other tests. The task you asked me about it years ago was, had to do with timing of simple kind of reward-based decision-making, where we see the same pattern where it's like patients with hippocampal damage seem to be trying extra hard to engage a system that they don't have. So why doesn't that shut off? And that might be partly related, it's pure speculation, but sort of to the interconnectivity of the hippocampus with other systems in the brain. So in that sense, it might behave differently than some kind of perceptual processing in terms of trade-offs and adaptiveness, but I don't know.
Thank you.
Okay, so just referring about your last comment about memory and uncertainty. So I'm
Yes. I'm pausing simply because I have so much to say about this. So a lot of the work we've done has to do with what you might think of as compression and how it leads to generalization in memory. But I deliberately didn't talk about that today, and I don't want to give you a whole talk. But we can talk more later. I think the short answer is that just like memory is not an accurate recording of what happened, forgetting is not arbitrary either, right? That forgetting is a tool for the shaping of memory. So if you accept the premise and the data suggesting that memory is adaptive and biased, but not because it's erroneous, but because it needs to be biased to help us in the future rather than just remember the past, then the way I think about forgetting is a part of one of the tools that helps that shaping happen. And that, yes, absolutely, part of that, part of forgetting and part of shaping has to do with generalization. It's useful sometimes to forget the details and remember the essence of things. That's what gives us things like schemas and semantic memory. And so I think forgetting is fundamental to the whole story.